Hello and welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and I must say that you guys are looking pretty decent now. You've been able to work with some of our number values, so you understand about booleans, integers and floats. We're going to take a look at scientific notation now. As we work through our scientific notation, you'll see that this becomes an easier way to express incredibly large numbers or incredibly small numbers. Let's just take a look at what we mean by this. Sometimes when a number is incredibly big, we're not certain whether we're looking at billions or trillions. And to be honest, for me especially, it's even worse when the number is small. Are we looking at tens of thousands or hundreds of thousands? It's very difficult, isn't it? So our scientific notation is here to help. So if we're looking at a million, we could express it as 1 multiplied by 10 to the power 6. That's what E6 means, 10 to the power of 6, or the exponent of 6. Looking at this number, which is now starting to get quite large, so with this I think we've got 1,000 million, but it's difficult to look at. And a couple of reasons. One, we're not using comma separators, which we'll look at later, and the other, it is just a little bit large. So we can go through and express this by 1 multiplied by 10 to the power 9. We're moving our decimal place 9 places to the right as we look at it. So we start off with 1, we move then our decimal place, so we end up moving our 1 further to the left. When we look at perhaps a smaller number, here we're looking at 1.23 multiplied by 10 to the power 5. So our decimal place was after the 1, but we now move it 5 spaces, so we end up with 123,000. Now, although this isn't particularly difficult to read, it would aid us humans if we had our thousands separator in. If we assign the value to a variable, here I'm just assigning it to a variable called number, then we can go through and print out that number. But rather than just printing the number variable, if we've got Python 3.6 or later, we can use F printing or format printing. So we open up our parentheses for print and add in then our F before the quotes. Our variable is going to be contained within our brace brackets, and any formatters we have following the colon. Here I've just added in the comma. So the printout will be 123,000. Now, not only can we deal with very big numbers, we can deal with smaller numbers as well. So we could then specify 1.23 to the power of negative 10, and we end up moving our decimal place to the left instead of the right. Here we're moving our decimal place 4 places to the left. So the number that we're representing represents 0.000123. Now, to see this happening, we're going to go out to the demonstration, and I do hope you follow along too on your own system. So we're going to take a look at using scientific notation as well as using fprint to format our numbers to make them more readable. Now, there is no point talking about scientific notation. It's a matter of seeing scientific notation working in Python. So let's dive out through to our Jupyter notebook and see what we mean by scientific notation. The reality is, as humans, we don't deal with very big or very small numbers very well. They're quite difficult to speak, to evaluate, for us to tell people the size of that number. So that's where we have scientific notation. We can start off with some really tiny numbers to begin with, so where we don't need scientific notation. Let's have a look at 1E0. 0. 1 to the exponent or power of 10 to the power 0. So 1 times 10 to the power 0 is 1. We don't move our decimal place in any direction, and we just get a float coming back of 1. Okay? Well, let's start increasing this a little bit. So 1 to the exponent or power of 10 to the power 1. As we look at evaluating this, we've moved our decimal place 1 space to the right as we look at it. So we get 10. If we try it to the power 2, we get 100 as we've moved 2 places. And of course, if I tried it to the power 3, we would get 1,000. Now, these are all numbers that we can express relatively easy. As we go through now and look at 10 to the power 3, we can see then that we have 1,000 coming out. Now, we can work with complete numbers like 1, but we can also work with fractions. So if we do 1.23 to the exponent of 10 to the power 3, we can see then that we've moved our decimal place the same 3 places. So we end up with 1,230. Now, whilst it's easy to deal with numbers of this magnitude, when we start increasing, so let's go through and put to the power of 10 to the power 10. Now, when we look at executing this, we can see that we've got quite a large number coming back. And it's hard for me to evaluate this or give any meaning to a number of this magnitude. So it's much easier to call it 1.23 times 10 to the power 10. We've moved the decimal place 10 places to our right. But now we might also look at when we are printing this, it is difficult to actually even see the thousands. So if we assign now our evaluation to a variable number is assigned a value of 1.23 times 10 to the power 10. When we look at printing it, within our print statement, we can also use format printing. So F strings, as they're called. This came in Python 3.6. So as long as you're using a recent edition of Python, then this is going to work for you. So we use then F and then open up our quotes. Our variables go in brace brackets. And if we just needed to combine our variable with text, we would close the brace bracket now and have text following the brace bracket. But we want to format the variable, so we use the colon, and we want to add in our comma separators. We can then close off our variable, close off our string, close off our parentheses for print. Now, when we look at it, we can start understanding the number more easily, but it's still difficult to express. So this would be 12,300,000,000, and that's our number. But yeah, it's much easier to specify this as 1.23 times 10 to the power 10. But you know, it doesn't just stop here. So far, we've been looking at multiplying by a positive exponent. We can also multiply by a negative exponent, meaning that we move our decimal place to the left. So if we start with 1.23 again, but this time if we use it multiplied by the exponent 10 to the power minus 4, we have moved our decimal place now 4 places to the left. So we now have 0.000123.